There we go, and we're live. All right. So we're working with gravity today, dealing with periods and orbits. So we've got this spacecraft of mass m that's moving in a clockwise circular orbit of a radius r around Earth, as shown above. The mass of Earth is the mass of Earth, me. First thing I want to do is draw and label the forces that are acting on the spacecraft. Where would I draw my arrows?
There is a force acting inside inside the Earth.
Okay, a force acting towards the Earth.
Towards the Earth.
Oop. Can I not add notes? I might not be able to add notes. There we go. Okay, so there's a force moving towards the Earth. What force is that?
Gravity.
Force of gravity, okay. Is there anything else that's acting on it right now?
No.
Nope, just force of gravity. Awesome. Okay, we would have a tangential velocity that's acting to that, but that's not a force, so we don't need to draw it.
Yeah.
We've got a second spacecraft of mass 2m that's placed in a circular orbit that has the same radius. Is the period going to be greater than, less than, or equal to the first aircraft?
Greater. Wait. You're doing A, right?
Oh, right, I skipped. I'm sorry.
Oh.
So that was B2. I guess it's more fair if we derive the period equation first, because then you'll be able to see if that changes anything.
Yeah.
Okay, let's do that first.
So we find the period. So it's pi square over r cubed is equal to pi square.
Okay, I think they're asking you to prove it though, so we can't just start with the period formula.
Oh, so centripetal force is equal to gravitational force.
Okay, perfect. Fg equals Fc. What's my formula for Fg?
Gmm over r square.
Gm E is the way they subscripted that for mass of Earth over r squared. Just to recap, what is this r squared?
Radius.
Not a radius, no?
Between two objects. Distance between two objects.
Distance between two objects from the surface to the surface?
From the center to center.
Okay, from center of mass to center of mass. Perfect. Okay, then centripetal acceleration, which is mv squared over r.
R.
For centripetal acceleration, what's this r?
Oh, that's the radius from... No, that's the distance from satellite to the center of the Earth.
Okay, so that means these two r's are the same, and we can manipulate them?
No. No? Wait. No, different.
This should be the same, right? Hold on. So centripetal
Oh, yeah.
acceleration
Oh,
is
yeah,
going to point
yeah.
towards the center of
This
mass.
one should be the same. Yeah, in this case.
Right. Okay, so for this one, that's the same. Um,
Mm-hmm.
and then I need to get rid of v, I think.
Yes, that's
So I
2
can't
pi
have
r
a v in our equation. So what's v?
2 pi r over period.
Okay.
Ah,
Okay, now this r is my
mm-hmm.
radius, is my distance from here to the center. So that is still the same.
Yeah. Yeah.
Okay. So that gives us GMME over r squared equals m over r times 2 pi r over t squared.
Yeah.
What's going to happen when we solve for t?
So m cancels out.
Is that the mass of Earth or the mass of the satellite?
Mass of satellite.
Okay.
And one one r cancels out from denominator.
Okay. So that'll leave us with 1 r on top. But then I can combine the
Yeah.
2 r's that are over here, so that'll give me 3 r's on this side. R cubed.
Uh-huh. So if you rewrite it first, then it's G M E equals 4 pi square over t square.
Okay, solve
So
for.
if we change and t square and then square root.
Okay. I have an equation for the orbital period t. I do need to solve for t then, so. Okay, if I take the square root, what's going to happen?
2 pi r. You can take out 1 r, right?
I could if we want.
No?
I think
Yeah.
this is normally left as r cubed on the inside, but just because
Oh
you've got
yeah.
that proportion.
Yeah, we can just keep it in. Yeah. Over GME.
Okay, but you are right. I can pull one of those r's out if you wanted to.
Mm-hmm.
Okay, so taking a look at this, if we were to take a spacecraft of mass 2 times the spacecraft that we have, but put it at the same orbital radius, would the period change?
No.
No. So what should this answer be?
Equal to.
Equal to. And for reasoning, we could say that something like the period does not depend on the mass of the spacecraft.
Mm-hmm.
Okay, do we need to explain anything else? Nope, that's it. Okay. Part C. Our Original spacecraft is moved into a new circular orbit that has a greater radius. Will the speed of the spacecraft be greater than, less than, or equal to the original speed?
Greater. Wait, is the speed r increases, right?
R increases.
Can I see the equation
Yep.
again? Yeah, then increases.
Okay, if we've got a greater radius,
But what do we check? I didn't see the question. As radius increases,
um,
period also increase.
as radius increases, what happens to the speed?
Oh, speed.
Mhm.
Um, mm, so 2 pi r over period is velocity. Isn't it increases?
Um, what's going to happen to your period if the radius increases?
Because r increases,
Mm-hmm.
period increases.
Okay. So right now for your velocity equation, this r is increasing and your period is increasing, so that doesn't help us. But if we
Yeah.
plug in this r, or plug in this t rather, we can see what happens to our r total. So this will be 2 pi r over rt. 2 pi, I am going to pull out the r this time, the way that you wanted to. R times root r over gme.
Oh, so 2 pi r all cancels out.
Right.
Oh, then it decreases as r increases. It's inversely proportional
Okay, so as
relationship.
r increases, the velocity will decrease.
Yeah.
Okay, so the original speed, sorry, the speed of the new orbit will be less than the original speed. The reasoning why, the speed decreases as the orbital distance increases. As proven by our derivation in part B. Oh, I guess that's it. I would probably add this. V equals 2 pi r over t, and then 2 pi r over 2 pi r roots r over gme equals 1 over square root r over gme, and therefore the velocity is inversely proportional to the square root of the radius.
Yep.
Just to be safe. Okay, any questions on what we did?
No. Oh, and going to school, right?
Did you get a message from Miss Martinez?
No, but I heard might go back to school on May 6th.
The last I heard, our inspection's happening, was supposed to happen today, but it's actually happening tomorrow. The high school teachers, assuming that inspection goes well, will be back on Monday. And then the plan is to ask the students to come back on Tuesday next week. However, that's not final until we get our inspection results back.
Oh, what if some students are still not in Shanghai?
Then they'll have to telecommute.
Hmm. Okay.
All right. Um, so thanks a lot for coming, and I'll see you tomorrow for Calc 2.
And the homework is on AP Classroom, right?
I've got the homework on AP Classroom. I'm also going to send you the rest of this free response packet. I think I already have, which is questions 2 and 3
Mm-hmm.
for the Physics A stuff. So I feel like we're going to need the practice for the Physics 1 stuff too.
So Physics 1, 2, and 3 and AP Classroom.
Right.
Okay.